Hello everyone. In the last video, we explored three key laws of indices, such as the multiplication law, the power of a power law, and the power of a product law. So far, we're working with positive integers like 1, 2, 3, 4, and so on. For example, we said 5 raised to the power of 3 means multiplying 5 by itself 3 times. But what if you raise 5 to a negative exponent like -1? Or what if you raise 5 to the power of 0? To help you discover the answer, let's look at a pattern and see if you can figure it out yourself. So we start by introducing a table. In the first row, we have values of n like 1, 2, and 3. And in the second row, we are expected to fill in the results for 5 raised to the power of n. Now take a moment and see if you can complete the table. Alright, so when n is equal to 1, we have 5 raised to the power of 1. Which means 5 is used only once in the multiplication. So 5 raised to the power of 1 is simply 5. When n is equal to 2, 5 raised to the power of 2 is the product of two 5s. So 5 raised to the power of 2 is equal to 5 multiplied by 5. And lastly, when n is equal to 3, 5 raised to the power of 3 is the product of three 5s. So 5 raised to the power of 3 is 5 multiplied by 5 multiplied by 5. Now, with these results, here's the pattern to notice. To get this value, we can take the previous value, which is 5, and multiply it by 5. Similarly, to get this value, we can take the previous value, which is 5 times 5, and multiply it by 5. So now we've seen how you can generate values to the right of the table. Let's see if you can generate values to the left. So to get this value, we divide the previous value by 5. And to get this value, we divide the previous value by 5. Now say we introduce more values to the left of our table. Using the same pattern we apply to find values on the left, can you determine the values of 5 raised to the power of n when n is equal to 0, -1, and -2? So to get this value, we take the previous value and divide it by 5, which gives us a result of 1. And to get the next value, we divide this value by 5, which gives us 1 divided by 5. And finally, to get this value, we divide the previous value by 5, which gives us 1 divided by 5 multiplied by 5, which we can simplify as 1 divided by 5 raised to the power of 2. So great, by following the pattern, we've now determined what happens when we raise 5 to the power of 0 and to negative exponents. Now let's focus on one key result. Here, we found out that 5 raised to the power of 0 is equal to 1. This leads us to an important law of indices called the zero power law. This law states that any number, as long as it is not 0, raised to the power of 0 is always equal to 1. For example, 7 to the power of 0 is equal to 1, -2 raised to the power of 0 is equal to 1, and 2 multiplied by 6 all raised to the power of 0 is equal to 1. Now let's bring back our table and focus on these values. We found that 5 raised to the power of -1 is equal to 1 divided by 5. And remember that 5 can also be written as 5 raised to the power of 1. This means 5 raised to the power of -1 is the same as 1 divided by 5 raised to the power of 1. We also got that 5 raised to the power of -2 is equal to 1 divided by 5 raised to the power of 2. This pattern leads us to the next law of indices called the negative index law. This law states that any number, provided it is not 0, raised to a negative exponent is equal to 1 divided by that number raised to a corresponding positive exponent. Now, the reason 0 is excluded is that if we substitute a is equal to 0, the expression a to the power of m becomes 0. This will result in division by 0, which is undefined. An example we can look at is when we raise 7 to the power of -2. Using the law we just introduced, we can write this as 1 divided by 7 raised to the power of 2. Now let's see what happens when we divide two expressions in index form that have the same base. For example, say we have 4 raised to the power of 5 divided by 4 raised to the power of 3. Expanding the numerator and the denominator, we get the following. Now notice that we can cancel out 3 4s from both the numerator and the denominator. This leaves us with 2 remaining 4s, which we can simplify as 4 raised to the power of 2. Now what happened was that we originally had 5 4s multiplying themselves in the numerator and 3 4s multiplying themselves in the denominator. After cancelling out 3 of them, we were left with 5 minus 3 4s, which simplifies to 4 raised to the power of 2. With this in mind, we can now introduce the last law in this video, which is called the division law. This law states that when dividing two numbers or expressions with the same base, we subtract the exponents provided that the base is not 0. An example we can look at is 5 raised to the power of 3 divided by 5 raised to the power of 7. Now, the first thing to notice is that these two expressions have the same base, so we can apply the division law. So this gives us 5 raised to the power of 3 minus 7, which simplifies to 5 raised to the power of minus 4. And remember that from the negative index law, we can write this as 1 divided by 5 raised to the power of 4. And that brings us to the end of this video. In the next video, we'll be looking at fractional indices and introducing the final law. Then in a later video, we'll focus on solving questions based on everything we've covered so far. Feel free to try the questions on the screen and post your answers in the comments.